Hello friends, welcome to this video on common failures in a DC machine and their possible remedies. In this video we will look at the common failures in the various parts of the DC machine and the possible remedies of each of the failures. There are a number of common failures in a DC machine. They are as a result of 1. Electrical failure, 2. Mechanical failure, 3. Operational and maintenance failure. Electrical failure refer to faults or malfunctions that occur in the electrical components or circuits of a machine or system, preventing it from operating correctly. This includes 1. Armature winding short circuit or open circuit. 2. Field winding failure. 3. Commutator faults. Now let us look at the first electrical fault, that is armature winding short circuit or open circuit. Cause: insulation breakdown, vibration, or excessive heat. Effect: sparking at brushes, uneven commutation, loss of torque. Remedy: test windings using a growler, multimeter. Rewind or replace faulty coils. Ensure proper insulation class and varnishing. Let us look at the next electrical failure, field winding failure. Cause: loose connections, overheating, contamination, insulation failure. Effect: weak magnetic field, low output voltage or torque. Remedy: proper maintenance, e.g. inspect and lubricate bearings regularly. Prevent overheating. Prevent electrical issues, e.g. use the correct DC supply voltage. Address mechanical and physical damage. The other electrical fault is the commutator faults. Cause: dirt, uneven wear, high mica, or poor brush pressure. Effect: sparking, voltage fluctuations, increased brush and commutator wear. Remedy: clean and undercut mica. Polish or skim the commutator surface. Correct brush pressure. EMF commutation, using interpoles. Commutator and brush maintenance. Proper brush alignment. Now let us look at the next common cause of failure in DC machines, that is mechanical failure. Mechanical failures refer to problems or breakdowns that occur in the physical or moving parts of a machine due to wear, stress, misalignment, or poor maintenance. They include 1. Bearing failure. 2. Shaft misalignment or bending. 3. Cooling fan or ventilation failure. 4. Loose fittings or bolts. 5. Rotor imbalance. The first mechanical failure that we will look at is the bearing failure. Cause: poor lubrication, contamination and improper installation. Effect: noise, overheating, vibration, reduced efficiency and performance and rotor rubbing. Remedy: improve lubrication practices. Control contamination. Enhance installation and alignment. Manage electrical damage. Monitor and inspect. The next mechanical failure that we will look at is shaft misalignment or bending. Cause: installation and foundation issues, operational and environmental factors and internal component failure. Effect: increased stress and wear and reduced performance and efficiency. Remedy: precision alignment, predictive and preventive maintenance, repairing a bent shaft. The next mechanical failure that we will look at is cooling fan or ventilation failure. Cause: dust, blade damage, blocked vents and bearing wear. Effect: overheating, insulation failure, equipment damage, burning smell. Remedy: clean vents regularly. Replace or repair the fan. Improve ventilation and airflow. Monitor temperature and performance. Ensure proper installation. The next mechanical failure that we will look at is loose fittings or bolts. Cause: vibration and shock loading, thermal expansion and contraction, under tightening, component wear and embedding. Effect: excessive vibration and noise, bearing and shaft damage, overheating. Remedy: tighten and lock fasteners. Perform regular inspections. Ensure proper installation. Correct misalignment. Replace worn components. The next mechanical failure that we will look at is rotor imbalance. Cause: manufacturing and assembly issues and operational and maintenance issues. Effect: excessive vibration and noise, accelerated bearing wear, reduced efficiency. Remedy: diagnostic steps, vibration analysis, visual inspection and isolation test. Correction procedures, cleaning and dynamic balancing. Mechanical repairs, redesign or overhaul. Now let's look at the other common failure in a DC machine, operational failure. Operational failure in a DC machine, or any electrical machine, occurs when the machine fails to perform its intended function properly due to incorrect operation, human error, or misuse. It is not caused by a fault in the design or materials, but rather by how the machine is used. They include 1. Overloading. 2. Overvoltage or undervoltage. 3. Improper starting or stopping. 4. Wrong direction of rotation. 5. Poor ventilation. 6. Incorrect brush setting or pressure. 7. Frequent starting and stopping. 8. Unbalanced load distribution. Now let us look at the first operational failure, that is overloading. Cause. Mechanical overload, electrical faults, sudden load variations, wrong selection of machine, failure of control systems and improper maintenance. Effect. Excessive heating, insulation damage, reduced efficiency and power losses, brush sparking and commutator wear, bearing failure and mechanical vibration and permanent damage. Remedy. Avoid exceeding rated load. Use overload protection devices. Regular maintenance. Install proper cooling, ventilation systems. Select correct motor rating. Monitor current and temperature. Train operators. The next operational failure that we will look at is overvoltage. Causes. Faulty voltage regulators or control circuits, incorrect supply connections, sudden load disconnection, lightning or switching surges, improper excitation control and unstable power supply. Effects. Excessive current flow, insulation breakdown, commutator and brush sparking, damage to electronic control devices, reduced machine lifespan and magnetic saturation of the core. Remedy. Use automatic voltage regulators. Install surge arresters or suppressors. Ensure proper excitation control. Regular inspection of control circuits. Avoid sudden load disconnection. Monitor voltage levels and use correct supply rating. Now let us look at the next operational failure, that is improper starting and stopping. Causes. Starting the motor directly on full supply voltage, failure of the starting resistor or starter, sudden stopping of the machine, incorrect operation by untrained personnel, faulty or bypassed protective devices and frequent on-off operations. Effects. Excessive starting current, mechanical shock or vibration, brush and commutator wear, overheating, reduced machine life and possible reversal or loss of control. Remedies. Always use a DC starter. Ensure protective devices are functional. Train operators. Use automatic control systems. Avoid frequent switching and perform routine checks. The next operational failure is wrong direction of rotation. Causes. Reversal of supply polarity, incorrect connections, faulty motor controller or VFDs, power supply issues, incorrect driver settings. Effects. Mechanical damage, failure to perform intended function, commutation problems and reduced efficiency or no output. Remedies. For 3-phase motors, swap any 2 of the 3 power leads. For DC motors, reverse the polarity of the voltage being supplied to the motor. For VFD-driven motors, check the VFD settings to ensure the motor isn't intentionally set to reverse. For single-phase motors, modify the wiring by swapping the terminals for the start winding, and a reversing switch can be used to change the direction of rotation without manually changing wires. Now let us look at maintenance failures. Maintenance failure happens when a DC machine breaks down or malfunctions due to poor, irregular, or neglected maintenance practices. It results from not taking timely actions to inspect, clean, lubricate, or replace worn-out components. They include dirty commutator surface, worn-out brushes, loose electrical connections. 4. Lack of lubrication. 5. Worn bearings. 6. Dust and moisture accumulation. 7. Failure to replace defective parts in time. 8. Poor insulation maintenance. Let us look at the first maintenance failure, dirty commutator surface. Causes. Accumulation of carbon dust, oil and grease contamination, moisture and humidity, poor brush contact and lack of regular cleaning or maintenance. Effects. Poor electrical contact, excessive sparking, overheating, uneven commutation and rapid brush wear. Remedies. Clean the commutator, remove oil and grease, check brush pressure and seating, maintain a clean operating environment, regular inspection and maintenance and turning. The next maintenance failure is worn-out brush. Causes. Excessive friction, high brush pressure, poor commutator condition, incorrect brush grade, sparking or arcing, vibration or misalignment and overloading. Effects. Poor electrical contact, excessive sparking, reduced machine efficiency, overheating, damage to commutator surface, noise and vibration and complete failure. Remedies. Replace worn brushes. Smooth and clean the commutator. Adjust brush spring pressure. Ensure proper brush seating. Maintain correct alignment. Regular inspection and prevent overloading. Let us look at the next maintenance failure, loose electrical connections. Causes. Vibration, improper installation, corrosion and oxidation and age and wear. Effects. Overheating and fire risk, voltage drop and intermittent power, arcing and sparking and equipment damage. Remedies. 1. Inspection and identification. 2. Repair or replacement. 3. Preventative measures. For example, regular maintenance schedule and mitigate vibration. Let us look at the next maintenance failure: lack of lubrication. Causes: insufficient lubricant, lubricant degradation, contamination, wrong lubricant type and seal failure or leakage. Effects: increased friction and wear, excessive heat generation, abnormal noise and vibration and component damage and failure. Remedies: use the correct lubricant. Control contamination. Establish a maintenance plan. Thank you for watching our channel. Please like, share, comment and please don't forget to subscribe. May God bless you.